In the following diagram, O is the center of the circle. Angle O1 is equal to angle O2, which is equal to O3. OG is equal to HG, which is equal to X. OF is parallel to CG, and AB is parallel to HC, which is parallel to FE. Prove that A, triangle GOH, is congruent to triangle DOC, and B, hence prove that OCDG is a parallelogram. Let's start with part A. Prove that triangle GOH is congruent to triangle DOC. This diagram may look very intricate and you may not have too much experience with circles, but the circle is actually there to help you. Let's make triangle GOH purple and triangle DOC green. Now point O over here is the center of the circle, and we know that the radius is a line that runs from the center of the circle to a point on the circumference. The distance between the center of the circle and any point on the circumference will always be the same length. On our diagram, OH is a line from the center of the circle O to H, a point on the circumference. OH is a radius, so let's put a small blue line over here. OG is a line from the center of the circle to G, a point on the circumference. This is also a radius, so let's put a small blue line over here as well to show that OH and OG are the same length. OD is a radius, so let's put a small blue line over here and on radius OC as well. Now the question tells us that OG is the same length as HG, so we can put a small blue line on HG as well. These small blue lines show us that OH, OG, OD, OC, and HG are all the same length. Please remember that the plural for radius is radii. A circle can have one radius, but two radii. Now let's look for corresponding sides in our triangles. We can see that GO is the same length as DO. These are both radii of the circle, so we use radii as our reason. We can also see that OH is equal to OC because these are also radii. We don't know the length of DC, so we cannot be sure if it's the same length as HG, so we cannot use this side to prove congruent triangles. This means we have to look at the included angle. In triangle GOH, we are considering sides GO and OH, so O1 is the included angle. In triangle DOC, we are considering DO and OC, so O3 is the included angle. We need to show that these two angles are equal, but the question tells us that angle O1 is equal to O2, which is equal to O3. So we know that angle O1 is equal to angle O3 because this information has been given to us in the question. Now we have two pairs of corresponding sides that are equal and an included angle. So now we've proven that triangle GOH is congruent to triangle DOC, and we use SAS for side, angle, side. Hence prove that OCDG is a parallelogram. Let's start by making OCDG green. In part A, we proved that triangle GOH is congruent to triangle DOC. In the diagram, we can see that in triangle GOH, we have three equal sides. Remember that if two triangles are congruent, then corresponding sides are equal in length. All three sides of triangle GOH are equal, which means that all three sides of triangle DOC will be the same length as well. The blue lines on OC and on OD already show us that these two sides are equal. So let's quickly put a small blue line on CD as well. Now we can see that OG is the same length as CD. So we can make a note and we can say OG is equal to CD. And as our reason, we say because triangle GOH is congruent to triangle DOC. We've already proven this. We don't need to prove it again. So as our reason, we can simply say proven above. Now we have one pair of opposite sides that are equal, but without the length of GD, we cannot prove the other pair of opposite sides equal as well. So we need to look for other information. The only way to prove that OCDG is a parallelogram is to prove that OG is also parallel to CD. Now, the question tells us that OF is parallel to CD and OG sits over here on OF. So now we can say that OF is parallel to CD, and we know this because this has been given to us in the question. Therefore, we can see that OG that sits on OF must be parallel to CD as well. Now we have two opposite sides that are equal and parallel. So as our final answer, we can say OCDG is a parallelogram because one pair of opposite sides are equal and parallel.